Hey, friends. All right. This note actually begins and ends our factoring chapter. Okay. Uh, we have created factoring review as its own little section in your course. And we kind of have done that for, I would say, two main reasons. Reason number one, it's super important. 80% of 20-1 is, do you know how to factor? The fun thing about 20-1, though, is factoring itself isn't the question. Factoring is a strategy you use, a process you use to get to an answer in a question. And so that's kind of the deeper layer compared to what you would have done in 10C. Okay. Reason number two, for those of you who are doing outcome-based assessment, no matter what your school is, um, this factoring is its own kind of packaged outcome. And so I think it's just easier to treat it as its own unit, and we'll go through it, we'll assess you on it, and then we'll be done with it. Except we'll never be done with it because we're going to use it for the rest of this course. Okay. Yeah, so this is lesson one, and it's your first and it's your last lesson in factoring. Okay. But what we want to do today is we're going to go through kind of the main different types of factoring questions that we asked you in grade 10. And the purpose of this is just to make sure you are all feeling good and you're all on the same page. Okay. Um, when we get into trinomials, I do want to just quickly say this before I get going. I am going to, for every question I give you here, I will go through kind of what I would call the process of decomposition, if you remember that from grade 10. Okay, there's going to be lots of grade 11 teachers who try and steer you away from that, and for good reason. Okay, please don't hear that I'm knocking your teacher. That's not what I meant by that. Um, you need to be able to factor quickly, and what we would ideally want is for you to be able to figure out the factors just in your head, just your knowledge of how these things work. Okay. If that sentence stresses you out, friends, decomposition is always going to work for you. So use it. Okay. It will take you a little bit more time. It may mean that time is a little bit more of a factor on your test, but it will work for you. Okay, so don't get yourself too stressed out. If you're trying other things and it's not working, decomposition is your best friend. It will always work for you. Okay, but before we get to decomposition, we're going to first look at the very basic, which is taking out a greatest common factor. Okay, so we will be using factoring in almost every unit. I'm just going to hide my head here for one sec so you can see the words. For this entire course, the methods of factoring that we learned in 10C are extremely useful in determining the x-intercepts of polynomial functions. Later, we will learn other applications of factoring polynomials. So for today, we are going to just review some strategies together, and it's going to make us super happy. That's why that little smiley face is there. It's going to be awesome. Okay, the greatest common factor. Now, when we're talking about a greatest common factor, we're looking across terms and we're saying, okay, what's common to each of these terms? So I'm actually going to do this. Let's just deal with the numbers first. What's common between a 5 and a 25? Well, a 5 is common. Okay. Then I'm going to look at, I'll just switch colors here and keep it nice and neat, an x squared versus an x cubed. So that's like an x squared is x times x, and an x cubed is like x times x times x. Okay, well, what's common is two of those x's. So x squared would be common. Okay, then I'm going to look at the next section, the y's. I've got a 1y here and I've got 4y's here. So it's like I've got a y with a y, 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 y. Well, what's common? 1y is common. Okay, and so 1y becomes part of my greatest common factor. So that is the greatest common factor. It is the thing that is shared from both of those terms. Okay, the word factor means to create a multiplication sentence. I don't know how to spell multiplication. Multiplication sentence. Okay, so what I want you to notice right now is this is a subtraction statement, right? It's one term minus one term. What we're doing when we're factoring is we're going to pull out that greatest common factor, and then what are we going to put? We're going to put an open bracket. Well, what do those brackets mean? It means we've created a multiplication sentence. We're going to multiply 5x squared y by whatever's in here. Now, in order for that to work right, what goes in here has to multiply by 5x squared y and get the original question. Otherwise, we're changing the value of the question. Okay, so when we're trying to figure that out, essentially, we just divide each of our terms by the factor that we're pulling out, like that. Okay, so this is a number divided by itself. Do you know what a number divided by itself is? Yes, yes, you do. Don't say nothing and don't say 0. I don't like those ones. 7 divided by 7 is 1. 11 divided by 11 is 1. Negative 18,000 divided by negative 18,000 is 1. You got it. Okay, so that one's going to be 1. 5x squared y divided by 5x squared y is a 1. Now, the next term, I've got negative 25 divided by 5. That'll be negative 5. I had x cubed divided by x squared, so that'll be x. And then y to the 4 divided by y, that'll be y to the 3. Okay, so this is now my multiplication statement. I have taken the greatest common factor out of the original. Okay. Oops, sorry, I didn't mean to go that quick. Let me just go back there for a sec. Okay, now, as we go through these examples, just a reminder, you want to be pausing me, trying these yourself, and then going for it, okay? All right, next up, b times a plus 2 plus c times a plus 2. Well, what I want you to see here is, hey, I don't want to use black here. Let's use green. This guy and this guy, that's a common factor to both of those terms. If I had given you b times 2 plus c times 2, you would have said, hey, 2 is a common factor. Let's pull the 2 out, and I'd be left with 2 times b plus c. Well, that's exactly what I'm going to do here. A plus 2 is a common factor, so I'm going to pull out the a plus 2, and I'm going to be left with b plus c. So it ends up being a plus 2 times b plus c. This is called factoring by grouping, and it was a really, really important point in 10C when we were discussing factoring trinomials by method of decomposition. Okay. All right. Cool. A quarter x squared plus 3x plus 9. Now, the conversation I want to have here is we often like to have, we don't want to have a fraction on our first term here. We call that first term a leading coefficient, by the way. So right away, I'm going to say, hey, I want to pull out that 1/4. Okay, I want the trinomial I'm dealing with to not have that fraction there. Now, when I say pull out, I'm factoring out, which means I am dividing. Okay, so let's go back to junior high for a second. Let's think about our division rules. If I took something, I'm just going to say x. If I divided by a quarter, I'm actually saying x multiplied by the reciprocal, right? So dividing by a quarter is the same as multiplying by 4. So I'm going to look at this and say, okay, that means I'm going to be left with x squared. Right here, I'm going to be left with 12, right? You're asking yourself how many quarters fit into 12. Well, 4 quarters fit into 1, 8 quarters fit into 2, and then 12 quarters would fit into 3, okay? And then we've got the plus 36 there, okay? 9 times 4, or 9 divided by a quarter. Now, if that conversation is stressing some of you out, friends, I am never here to stress you out. Grab your handy dandy calculator, go 9 divided by bracket 1 divided by 4, and it's going to give you 36. Okay, so you can use your calculator to help you. I just want to push you to try and think it through in your head. If you can think it through in your head, you're going to feel a whole lot more better about it. That was not great grammar, but you know what I mean. Okay, now, that was the purpose of this question. I want to just take this question one step further to say, hey, I know I have a perfect square trinomial here. I know that this is going to factor into x plus 6 all squared. Please don't stress out about that. I just have to finish the question. I'm about to talk about those in just in one example or 2 more examples here, okay? So stay with me. I will show you how I did that in just a couple minutes. The purpose of this question was just to take out the greatest common factor, okay? All right, so now we're looking at 3a squared b plus 9a cubed b squared minus 12a to the 5 b to the 10. And I'm asking myself, okay, what's common to all of these? So I'm going to deal with just the numbers, deal with just the letters. From a 3, a 9, and a negative 12, I could take out a 3. From a squared, a cubed, and a to the 5, what's common there is a squared. There's at least two a's common to everything. And then I've got a b squared, and a b to the 10. So there'd be one b that's common to everything. So greatest common factor is going to be 3a squared b. 3a squared b is what I'll take out, put it in the front. Okay. Okay, so when I pull out the 3a squared b, remember what's happening is I'm dividing everything by 3a squared b, okay? So 3a squared b divided by 3a squared b, that's where the 1 is coming from. 9a cubed b squared divided by 3a squared b, 9 divided by 3 gives me 3. A cubed divided by a squared gives me a. And then b squared divided by b gives me b, okay? And then 12 divided by 3 is 4. Actually, you could talk about that being negative 12 divided by 3 gives me negative 4, right? Always think about the sign that's in front of the number. A to the 5 divided by a squared would be a to the 3, and b to the 10 divided by b would be b to the 9, okay? As kind of a check and balance, you should always have the same amount of terms inside the bracket as you did when you started, okay? Okay, awesome. That was the greatest common factor. Now we're going to move into looking at some trinomials. Now there are two types of trinomials. Old school teachers like myself sometimes will call these simple trinomials and complex trinomials. The difference is the one that you see on the left right now doesn't have a coefficient, and the one that you see on the right does. I am going to treat these, though, the exact same way. I'm going to walk you through a process called decomposition. Remember, I said I'm not always going to do this, but if you're stressed out about math and you've got a trinomial, decomposition will never fail you, okay? So right here, I'm looking for two numbers that multiply together to give me negative 6 and add together to give me negative 5. I know that those two numbers will be negative 6 and positive 1. Okay, negative 6 times 1 will give me negative 6. Negative 6 plus 1 will give me negative 5. So I'm going to decompose my middle number. Decompose just means to break down. So I'm going to take that negative 5 and I'm going to break it down into negative 6x plus 1x minus 6. Okay. Now, after that, I'm going to factor the front two and factor the back two. So that's going to give me x squared minus 6x. I can take out an x and I would be left with x minus 6. And then on the other, the back two here, I can take out actually nothing. So I'm going to take out a 1. And then that would leave me with x minus 6. Okay, and now I'm actually back to the greatest common factor conversation I had just a couple slides ago, that x minus 6 is actually common to both of these terms. So I would have x minus 6, and when I pull that out, I'm left with it being multiplied by x plus 1. Okay? So that is what decomposition looks like, and that's what I'll run through each time now. Now, you know this, but I should probably say it just to make sure we're on the same page together. The way these videos are meant to work, the way I'm hoping they're helpful to you, is by you actually pausing me many, many times throughout the video, you trying the question yourself, and then you watching how I do the question. Everything is easy when you watch somebody else do it. It's a little bit different when you're the one holding the pencil or pen and doing it yourself. So make sure if you want to get the most out of these videos, you need to shut me up several times, pause, try it yourself, then see what I do, okay? Okay, I'm going to clear that and just bring up the computer portion, which will say the same thing. Okay, and now we're going to head on over to the next guy. Now, the only difference here is I'm looking for two numbers that multiply together, just like I did the last time. It was neg 6 on the last question, okay, but really what it was it was 1 times neg 6, okay? You always have to take into account both of these numbers. So here, I'm actually looking for two numbers that multiply together to give me negative 10 and add together to give me negative 3, okay? Those numbers would be -5 and +2. I'm just wondering if my head is actually in the way of what I just wrote, so I'm just gonna hide for a quick sec so you can see what I wrote. I can't hide. There we go. Okay, just in case you can't see what I wrote there. Okay, and now we are going to carry on with that. We're going to break that -3x into the -5x and the +2x. Factor the front 2, factor the back 2. So I'm looking at 2x that I can take out of here, and I'll be left with x plus 1. On the back 2, if my first term that I'm factoring, this is the, let me just separate these out for you a bit so that you can understand what I'm saying. Okay, so if the first term here is negative, you always want to take out the negative, okay? So I'm actually going to take out a -5 there. That's going to leave me with x plus 1 in the brackets. Okay, and then I can see x plus 1 is common. I'll pull the x plus 1 out, and I'll be left with x plus 1 equals, or times 2x minus 5. X plus 1 times 2x minus 5. Okay. Awesome. Okay, next guy, 5x squared plus 35x plus 60. Now, some of you may go right away and say, oh, I'm looking for two numbers that multiply together to 300. Don't do that. Remember what I said a couple minutes ago. The first step in any factoring question is to ask yourself, do I have a greatest common factor? When I look at 5, 35, and 60, all of those things are divisible by 5. So the first thing I want to do is take out the 5 for two reasons. Number one, you have to. These questions are going to say completely factor. Number two, if you do it at the beginning, your numbers are all smaller and just easier to deal with. Okay, so if I take out the 5, I'm left with x squared plus 7x plus 12. Now I'm going to look at factoring this. I'm looking for two numbers that multiply together to give me 12, add together to give me 7. That would be 3 and 4. So again, some of you know that this is shortcuttable. You can go right to x plus 3 and x plus 4, and that's awesome if you know how to do that. I told you that for this lesson, I would do everything by decomposition, so that's what I'm doing. I broke my middle term down into the 3x and the 4x. I'm going to factor the front 2, factor the back 2. Out of the front 2, I can take out an x. Out of the back 2, I can take out a 4. Okay. If you are playing with decomposition, always make sure there's a symbol right there. That's really, really important. I see lots of kids forget that sometimes, and then their work actually doesn't communicate what they think they want to be communicating. Then I can see the x plus 3 is common, pull that to the front. So I have 5 times x plus 3 times x plus 4. Okay, 5 times x plus 3 times x plus 4. See, we are becoming factoring machines. It is amazing. You are amazing. Okay. Next one. 21x squared minus 36x minus 12. Again, first question I want to ask myself is, do I have a greatest common factor? I do actually. Both of or all of these are divisible by 3. So I'm going to take the 3 out first. That's going to leave me with 7x squared minus 12x minus 4. Now I'm looking for, remember that we got to multiply these guys together. So I'm looking for two numbers that multiply together to give me -28 and add together to give me -12. Okay, what's that? -14 and 2. So I'm gonna again go through decomposition. I'm gonna break my -12x into -14x and +2x. And then I'm going to factor the front 2, factor the back 2. Okay, again, here I am separating out the front 2 and the back 2. 7x squared minus 14x, I can take out a 7x. That would leave me with x minus 2. And then in the back 2, I can take out a 2, so that'll say plus 2, and I would be left with x minus 2. Which makes me super excited because now I can see I have a greatest common factor of x minus 2. Sorry, did I just say x plus 2 a couple seconds ago? I meant x minus 2. Please forgive me. Sometimes I don't listen to what I'm saying. You know, I tune myself out. Okay, so I have x minus 2 on both of them. X minus 2 is common. Pull the x minus 2 out to the front. So that's going to be 3 times the x minus 2 that I pulled to the front times what's left over. And what's left over is 7x plus 2. Okay, so 3 times x minus 2 times 7x plus 2. Okay? All right, now we're going to get into some special stuff. The first one being a difference of squares. Now, friends, I'm going to tell you, as someone who's been teaching for hundreds of years, for whatever reason, difference of squares, kids have a really hard time seeing. Okay, so let's just unpack this for a sec. Difference means subtraction. Okay, so we're looking for essentially a setup where we have a perfect square minus a perfect square. Okay, it can't be addition. That would be an addition of squares, and that's not something we work with. It has to be a difference of squares. Okay, so here I see x squared minus 16. X squared, I know the square root of that. It's x. And I know the square root of 16 is 4. Okay, so what happens when we have a difference of squares, I'm just going to write a random one here for a second, a squared minus b squared. It will always factor into two binomials multiplied together. The first term will be the square root of the first term. The last terms will be the square root of that last term, and then one gets added and one gets subtracted. Okay, that's how you handle difference of squares. So this ends up being x plus 4 times x minus 4. The square root of x squared is x. The square root of 16 is 4. And one gets added and one gets subtracted. Okay? All right. Awesome. Then we're looking at 36a squared minus 49b squared. Again, it's a difference of squares. The square root of 36a squared would be 6a. And the square root of 49b squared would be 7b. So I have 6a plus 7b and 6a minus 7b. Okay. Okay, 8d squared minus 32. Some of you may look at this and say, oh, nothing to do. Remember, the first step in any factoring question is to look for that greatest common factor. 8 and 32 actually have a greatest common factor of 8. I'm going to pull the 8 out. So if I pull the 8 out, that'll leave me with d squared minus 4. And that, friends, is a difference of squares. So now I can take that d squared minus 4 and factor it into d plus 2 and d minus 2. Okay, d plus 2 and d minus 2. Then, I love this one, q to the 8 minus 1. Okay, first of all, when I have high exponents, taking the square root, you have to think about this as, okay, let me just draw this out for you. Q to the something times q to the something equals q to the 8. These numbers have to be the same number, and when multiplying powers of the same base, you add them together. So what number could I put here and add it to itself and get 8? Well, that's going to be 4 and 4. So essentially, when I go to take the square root, I'm just dividing the original exponent by 2. The other thing I like about this question is kids forget that 1 is a perfect square, right? The square root of 1 is 1. 1 times 1 is 1. So this becomes q to the 4 plus 1 and q to the 4 minus 1. Okay, q to the 4 plus 1 and q to the 4 minus 1. Now, friends, the other reason I like this question is because now I can have a conversation as to we're not done. Remember, you want to factor until you can't factor anymore. So when I take a look at this, there is nothing I can do with that, friends, because that's an addition of squares. You can't do anything with an addition of squares. But this guy is a subtraction of squares. It's still a difference of squares. So I'm going to take that guy and go further. That'll be q squared plus 1 and q squared minus 1. And then I ask myself, am I done? And it's still, no, I'm not, because this guy here is still a difference of squares. That could be q plus 1 and q minus 1. Okay, and then you ask yourself, am I done? And the answer is yes, I am totally done now. Okay, good job. All right, now we're going to move on to some other special polynomials. This first one is partly a conversation around it's okay to have exponents on both ends of my friendly trinomial. Okay, as long as in the middle, the exponents represented on the respective letters are half of what the exponent on the outside letters were, we're good to go. I can still do decomposition. So I am still going to be looking for two numbers that multiply together to give me 1 and add together to give me -2. Well, that's going to be -1 and -1. Okay, so I'm going to go through the process of decomposition just like I have been doing. I'm going to take that middle term, which is -2xy. I'm going to break it down into -xy and -xy. Okay, and then I'm going to factor the front two and factor the back two. So I'm looking at x squared minus xy. I can take out an x and I'd be left with x minus y. On the back two, I can take out a -y and I'd be left with x minus y. So now I can see the x minus y is common to both. It's a greatest common factor on both of these terms. I can pull the x minus y out and I'd be left with x minus y. So I end up with x minus y times x minus y. Now, those are actually the same thing. So when you have a number multiplied by itself, we say that we square that number. So I would take this one step further and actually put it together with a square instead. This would be the best final answer possible. Okay. For those of you who like vocabulary, this is a perfect square trinomial. It's a perfect square trinomial because it factors into a binomial all squared. It factors into a binomial times itself. We call 81 a perfect square because we know that 9 squared is 81. So we call this guy a perfect square trinomial because its square root is x minus y times itself. Okay. Okay, let's try this guy. Very similar thing, okay? One difference here, though, is now I have this x to the 4. Again, I already said this, though. As long as the exponent in the center is half the exponent on the outside, it's friendly. We're good to go. So I'm looking for two numbers that multiply together to give me 20, the 5 times 4, and add together to give me -21. That'd be -20 and -1. Okay, so I broke down my -21 x squared y. Remember, whatever goes with the original middle number there has to go with both numbers that you're breaking down, right? Because you're adding those back together to get what that top number guy was. Okay, then I'm going to factor the front two, factor the back two. From the front two, I could take out a 5x squared. That would leave me with x squared minus 4y. And then on the back two, I want to take out a -1, and that would also leave me with x squared. Oh, sorry, no, I want to take out a -y, not just a -1. Look, y is common to both, okay? So take out a -y, and that would leave me with x squared minus 4y. I can then see that the x squared minus 4y's are common to both of them. Pull that to the front, x squared minus 4y times 5x squared minus y. Okay. Awesome. We got this. We got this. Okay. 24a to the 6 plus 28a cubed minus 12. Again, the first thing I'm going to do here is not figure out what 24 times 12 is. I'm going to look for a greatest common factor. The greatest common factor in all three of those numbers is a 4. So let's take the 4 out. Look how much nicer that is. Now I'm looking at 6a to the 6 plus 7a cubed minus 3. So now I'm looking for two numbers that multiply together to give me -18, the 6 times -3, and add together to give me 7. Well, I know that that's going to be 9 and -2. Okay, so I'm going to break my middle term down into the 9a cubed and the -2a cubed. I'm going to factor the front two, factor the back two. I can take out a 3a cubed from the front two, and then I took out a -1 from the back two. And then I can see, hey, I've got the same thing in the brackets. Yay for me. Pull that to the front. So I'm going to have 4 times the 2a cubed plus 3 times what's left over there is the 3a cubed minus 1. Okay. 3a cubed minus 1. Awesome. Okay, friends, let's go to the next example. And we see this one looks a little more scary, but I'm going to try and keep it as not scary as possible. Okay, what I want you to think about here is this still is a friendly looking, some of you may not say it looks all that friendly, but I would call this a friendly looking trinomial because I have something squared minus 3 times the something minus 4. So the way I would maybe approach this is let's make a substitution, okay? Let's follow me here. I'm going to say that 2x, oh, that's a small typo there. This should say 2x plus 1, sorry. 2x plus 1 is a, okay? 2x plus 1 is a. Just make sure you write 2x plus 1 there, okay, friends? Okay, so if I call that a, then everywhere where I see the 2x plus 1, I can just replace it with a. So that'll be a squared minus 3a minus 4. Okay, that is super easy to deal with. I'm looking for two numbers that multiply together to give me negative 4 and add together to give me negative 3. I know that that's negative 4 and positive 1. Again, I'm going to do the decomposition because I said I would. Some of you know to go right to an answer, and that's totally fine. Even encouraged, okay? Okay, but I end up with x minus 4 times x plus 1. Okay, x minus 4, sorry, not x, a minus 4 times a plus 1. Okay, now that's not my answer. We do have to have a quick reality check here. We were never dealing with a, we were dealing with 2x plus 1. So once I've done the factoring, I got to put the 2x plus 1 back. So everywhere where I see a, I need to put that back as 2x plus 1. So instead of a minus 4, now I'm saying 2x plus 1 minus 4. And instead of saying a plus 1, I'm saying 2x plus 1 plus 1. Okay? Now, of course, I'm going to clean this up a bit. 1 minus 4 is negative 3, so I can just simplify that. And then 1 plus 1 is 2. Then there's one more step to do here. And the one more step is I can look at this guy right here and say, oh, look, there is now a greatest common factor there of 2. I'm going to pull that 2 out. So if I pull it out, I'm just going to put it at the front. Okay. And then what happens when I pull it out? Oh, I'm going to be left with x plus 1 as that last term instead because the 2 came out. Okay. So something like that. Okay. Awesome. Oh, I cleared my ink, so I want to say one more time, this is a typo right here, friends. Just make sure that says 2x plus 1 there. Okay? All right. Awesome. Let's go to the next one. Very similar, except now they don't say the same thing. So then you're like, Hill, what are you doing to us? What are you doing to us? Well, what I want you to see here is it's a difference of squares. Okay? 36 is a perfect square. 3x plus 5 squared is a perfect square. So if those two things being multiplied together are both perfect squares, then this whole thing is a perfect square. And this whole thing is a perfect square. And I'm subtracting. So it's a difference of squares. Okay. It's a difference of squares. And we know that when we do a difference of squares, it ends up being square root plus square root times square root minus square root. Okay. So I'm asking myself, okay, don't get stressed. I can feel the tension. I need to figure out the square root of this. Well, what is the square root? Look, I'm just going to do this with you. We'll go piece by piece, okay? What's the square root of 36? 6. Easy. What's the square root of 3x plus 5 all squared? Now, don't make your life complicated. What's the square root of 9 squared? Oh, it's just 9, right? Think about it for a sec. So the square root of 3x plus 5 all squared, oh, it's just 3x plus 5. Done. Okay, so that's my front guy, 3x plus 5 times 6. Okay, now the back guy, what's the square root of 9? Oh, that's 3. And what's the square root of 5x plus 7 all squared? Oh, that's 5x plus 7. So 3 and 5x plus 7. And then what happens? One of them gets added and one of them gets subtracted. Done. Now, I'm not done. I have to clean that up, okay? But that's where we are. So that should be this guy right there, okay? Now, I'm going to distribute the 6, I'm going to distribute the 3, I'm going to distribute the 6, and I'm going to distribute the negative 3. Just be careful of that guy, right? So this is going to give me 18x. Let me just draw it with you. 18x plus 30, 15x plus 21, 18x plus 30, negative 15x, negative 21. Okay. So then I can go, okay, 18 plus 15 is 33. 30 plus 21 is what, 51? Then here I'll go 18 minus 15. I'm just combining like terms, right? 18 minus 15 is 3, and then 30 minus 21 would be 9. Okay, and then I'm looking to see, first of all, look how nicely this cleaned itself up, okay? So this wasn't as bad as maybe you thought it would be, or hopefully it's not as bad as maybe you thought it would be. But I'm not quite done yet. I still want to look for greatest common factors after I've done all that simplification, right? Sometimes they'll show up again. 33 and 51 are actually both divisible by 3, and 3 and 9 are both divisible by 3. So I'm actually going to take out a 3 from both. So I took out the 3 from the first guy, and that's leaves me with 11x plus 17, right? 33 divided by 3 and 51 divided by 3. And then I took out a 3 from the second guy, and that left me with x plus 3. Now, I'm not quite done yet because I can put those two 3's together, right? This is just this times this times this times this. So I know that 3 times 3 is 9. So let's simplify that one step further, and we'll have a final answer of 9 times 11x plus 17 times x plus 3. Okay? Awesome. See, we can totally do this. This is going to be awesome. Just think, we get to do this all year. Okay. I really like 20-1. Next one. Okay, back to kind of that friendly looking trinomial. We're going to make a substitution, get rid of the x or the a plus 5 for a minute. So if I said, hey, let's let a plus 5 equal b. Okay, it doesn't really matter what you let it equal. But now I'm looking at 20b squared plus 60b plus 45. Now, those are large numbers. I probably want to think right away, hey, do I have a greatest common factor that I can deal with here? And the answer is yes, I can take out 5. So if I take out the 5, that leaves me with 4b squared plus 12b plus 9. Okay, so now I'd be looking for two numbers that multiply together to give me 36, 4 times 9, and add together to give me 12. I know that that's 6 and 6, so I'm breaking my 12b into 6b and 6b. I'm going to factor the front 2. I'm going to factor the back 2. In the front, sorry, in the front 2, I can take out a 2b or not 2b. That's the question. Sorry, okay. I can take out a 2b. And that'll leave me with 2b plus 3. And then in the back 2, I can take out a 3, and that'll leave me with 2b plus 3. So now I see the 2b plus 3 is common. Pull that to the front. Hey, I'm left with 2b plus 3 again. That was a perfect square trinomial. That's exciting. Let's put that together. So that'll be 5 times 2b plus 3 all squared, right? Except now is the time for our reality check because b was never there. B's not b. B is a plus 5. So I'm just going to sneak the a plus 5 back, and then I'll clean this up. So when I go to clean this up, I've got 2a, and then I've got 10, and then plus 3. So I know 10 plus 3 is 13. So I'm just going to go right to saying that's 2a plus 13. Okay? Awesome. All right, friends. That is our quick, maybe not that quick, but that is our review of factoring. Hopefully this has helped. For some of you, it'll be a while since you dealt with factoring from grade 10. So hopefully this just gets the brain juices flowing a little bit better for you again. I've got some work for you to try if you're my kid at school, and I'll post that there. But for all of you, find some practice to do and do it. Practicing is so important in math. Hey, you know what? I'm so glad I get to take this journey with you. Thanks for watching this video and for letting me kind of tag along and hopefully help out. And I appreciate you guys letting your friends know about these videos as well. That's super, super awesome. So thanks for doing that. And as always, thank you so much for subscribing to my YouTube channel. All right, guys, you take care, and we will dive into another unit when you're ready. See you soon.